what I write about acceleration, I write that acceleration comes into action. Anta time Subaru? Meeranta winner. Isn't it? Sorry, so acceleration comes into action in which condition? Only when velocity of the body changes. Clear, ma? Only when velocity of the body changes, then only acceleration comes into action. If velocity does not change, there is no acceleration. Is it clear? And what is the definition of acceleration? The rate of change of velocity. The rate of change of velocity is called acceleration. Are you able to understand, ma? It means it is the ratio of change in velocity divided by time taken, or how fast velocity is changing with respect to time. That is also called as acceleration. Are you able to understand? So therefore, how can I write the statement of this acceleration? Acceleration can be written as v minus u divided by t. And what is meant by v here? V means, come on, final velocity. Final velocity. U, initial velocity. Clear, ma? And what is meant by t? T is called as time interval or time taken. So this is the definition of acceleration, mathematical expression of acceleration. A is equals to v minus u divided by t. Or same acceleration you can write it as acceleration is equals to, so v1 minus v2 divided by t, v2 minus v1 divided by t. Or also you can write it as v2 minus v1 divided by t2 minus t1 also. So these are the different forms in which I can write acceleration. Are you able to understand, ma? That's it. So now let us try to understand this acceleration by taking one example. We will take an example and we will try to understand acceleration. Clear, ma? For example, consider these are the different intervals which I am taking. Clear, ma? So this is position A, this is position B, this is position C, and this is position D. Clear? So body is traveling from A to B, B to C, and C to D. So here velocity at point A is 0 meter per second, velocity at point B is 2 meter per second, velocity at point C is 2 meter per second, and velocity at point D is 0 meter per second. So here the time taken, let it be 1 second, here also time taken is 1 second, here also time taken is 1 second. So totally how many intervals we have taken, ma? 3 intervals we have taken. Are you able to understand? A to B is one interval, B to C is another interval, and C to D is another interval. Now the question is, what is the acceleration between A, B? How you got to 2? What is the definition of acceleration, ma? Definition of acceleration is change in velocity divided by time taken. Vinali. Rayadamlone unnaru meeru. Clear, ma? Change in velocity divided by time taken. What is meant by change in velocity? Change in velocity means final velocity minus initial velocity, no, ma? So final velocity in this interval is how much? 2. Initial velocity 0. Time taken 1 second. So therefore what is the acceleration? Plus 2 meter per second square. So unit of acceleration is meter per second square. Okay, ma? Now when you see acceleration is 2 meter per second square, then what do you understand? Acceleration 2 meter per second square means what do you understand? Meekem artham avutadi? Next second ki 4. Ante what is increasing? Acceleration is constant. Velocity increases. Because acceleration is nothing but what? Acceleration is nothing but change in velocity divided by time taken, no, ma? It means for each second, how much velocity is changing, that is called as acceleration. Okay. Now what is the acceleration I got? 2 meter per second square, no? What is the meaning of this one? This can be written as 2 meter per second per second. Clear, no? So what is meant by 2 meter per second per second? So I got plus 2, no? Plus 2. Plus 2 indicates that for every second, the velocity of the body increases by 2 meter per second. That is the meaning of this. Are you able to understand, no? It means after, for example, if velocity is 0, after 1 second its velocity will be 2. After another second its velocity will be 4. After one more second its velocity will be 6. So like this velocity continuously increases. That is called as acceleration. Is it clear, ma? So meters per second, meter per second. What is this 2 here? 2 meter per second is called as change in velocity, or you can call it as increase in velocity. Why I am saying increase here? Because velocity is increasing. I have plus 2, no, ma? Plus 2. So increase in velocity. Clear? In how much time? Increase in velocity per 1 second or per unit time taken. Are you able to understand, ma? That is called as acceleration. It means velocity of the body is increasing by 2 meter per second every second. Clear? That's it. Similarly, can you say what is the acceleration between B and C? 0. Why it is 0? Velocity is not at all changing, no? Here what is the velocity? 2. Here what is the velocity? 2. Is there any change in velocity? Velocity is not changing, so acceleration is 0. Understood, no? Now can you say what is the acceleration between C and D? Minus 2 meter per second square. Why you got minus 2? So final velocity 0 in this interval. Final velocity is 0. Initial velocity is 2. Acceleration is final velocity minus initial velocity, no? Final velocity is 0 minus 2 initial velocity divided by time taken is 1 second. So acceleration is minus 2 meter per second square. And what is meant by minus 2? Velocity is decreasing by 2 meter per second every second. That is called as negative acceleration, or you can call it as deceleration, or you can call it as retardation also. Acceleration, there is only one name, acceleration, that's all. But for negative acceleration, we have 3 names. Negative acceleration, deceleration, retardation. Okay, anything can be asked. Okay. So therefore, let us calculate this one completed, no? So let us calculate the acceleration in the interval from B to C. So acceleration between B to C. Final velocity minus initial velocity divided by time taken. Final velocity is 2, initial velocity is 2, time taken is 1 second, so 0 meter per second square. It means velocity is not changing. Velocity is constant. There is no change in velocity. Clear, now? Similarly, if I take acceleration from C to D, clear? Then here also V minus U divided by T. Final velocity is 0, initial velocity is 2, time taken is 1 second, so minus 2 meter per second square. It means that negative acceleration indicates velocity is decreasing. Velocity is decreasing at what rate, ma? At the rate of, velocity is decreasing at the rate of 2 meter per second for every second. Okay? So this acceleration, we call it as negative acceleration, retardation, or you can call it as deceleration. Fine, ma? So if you want to write the names of them, you can write here. Negative acceleration, retardation, deceleration. Is it clear? That's it. Okay, ma? So therefore, what is the basic meaning of acceleration we have studied? Clear, ma? Now we will study about, okay, ma? So what is meant by average acceleration and instantaneous acceleration? Clear? So first of all, I will study average acceleration. Clear, ma? So what is meant by average acceleration, ma? Average acceleration means what? Come on. Total change in velocity. Total change in velocity divided by time taken. Clear, ma? So this is called as average acceleration. For example, if body is traveling in 2 intervals, 3 intervals, 4 intervals. So on the average, we will have some change in velocity, no? For the total journey. So that total change in velocity divided by time taken, then it is called as average acceleration. Clear, no? For example, let us try to understand this one by taking a graph. Clear? So for example, this is acceleration and this is time taken. Clear? So therefore, how can I draw the graph? Previously, not acceleration, but this is velocity and this is time graph. So previously we have drawn displacement to time graph, no? Similarly, I will draw this graph also. So for example, let us draw this graph. Graph is like this. So on x-axis we are taking time, on y-axis we are taking velocity. Clear, ma? So here time interval, let it be 2 seconds, here let it be 4 seconds, and here let it be 6 seconds. Clear, ma? So here the velocity is 10 meter per second. Clear, no, ma? So this is the graph which is given. Let it be point O, point A, point B, and point C. Clear? So question is, find acceleration, from where to where? Between first point O to A to B, third one, O to B, fourth one, B to C, fifth one, O to C. Clear, ma? So in these different intervals, you are supposed to find out acceleration. Okay, come on, try for. So let us see this question. No? This is the given question. No? So first of all, I will calculate acceleration between O to A. Clear, ma? O to A means from here to here, no, ma? Clear? So what is the equation of acceleration? Change in velocity divided by time taken. Okay. So this is the initial point, this is the final point. So at final point, what is the velocity? 10. At the initial point, what is the velocity? 0. Time taken is how much? From here to here, time taken is 2 seconds. So it is plus 5 meter per second square. So what does plus 5 indicate? Plus 5 indicates that velocity of the body is increasing. Velocity of the body is increasing. That is what we understand. So next you go for A to B. Clear, nama? A to B, second one. So from A to B, how is the graph? Okay, ma? So from A to B, how is the shape of the graph, ma? Straight line. Straight line means what? Velocity is not changing. That's the meaning of this one, no? At point A, what is the velocity? 10. At point B also 10 only. So change in velocity is 0. There is no change in velocity. If a change in velocity is 0, acceleration also 0. But body, is it in rest position? Body rest on the? No. Body is moving continuously with how much velocity? From in between 2 seconds to 4 seconds. Body is continuously traveling but with same velocity. Are you able to understand, ma? So body is not stopping. Its acceleration has become 0. It means increase of velocity or a decrease of velocity has become 0. But body is not in rest position. It is continuously moving. Are you able to understand, ma? So therefore, in between A and B, what is the acceleration? So A is equals to V minus U divided by T. Final velocity is 10. Initial velocity is also 10. Time taken is 2 to 4. What is the time taken, ma? 2 seconds. So therefore, it is 0 meter per second square. So that is the acceleration. Clear, na, ma? Next, third one. Acceleration between O to B. Clear? So in between O to B. So again, same formula. A is equals to V minus U by T. At B, what is the velocity? 10. At O, what is the velocity? 0. So 10 minus 0 divided by, and what is the total time taken from traveling from 0 to B, ma? O to B, it is 6 hours, 4 seconds. From here to here, total 4 seconds only, no? So divided by 4. So 10 by 4 is how much? 2.5 meter per second square. Third one. Acceleration between which points, ma? O to B. O to B already completed, no? Fourth one. So B to C. Okay, ma? So in between B to C, again same equation, A is equals to V minus U divided by T. Final velocity is 0, no? Final velocity is 0. Initial velocity? Final velocity at point B na? B to C is 0. Initial velocity at point B is how much, ma? 10. And the time taken is 4 to 6. Time taken 2 seconds. So total acceleration is how much? Minus 5 meter per second square. So what does minus 5 indicate? Minus 5 indicate that velocity is decreasing in this condition. Clear, no? Next, last one, O to C. Okay, ma? So O to C. So again, what is the acceleration? V minus U divided by T. What is the final velocity at C? 0. Initial velocity? Initial velocity is also 0. And what is the time taken? From O to C, total time taken is 6 seconds. Clear, no? So therefore acceleration is 0 meter per second square. So that is how we do the problems in the case of graphs. Understood, no? That's it. Make a note of this one. So at sometimes I got positive acceleration, sometimes I got negative acceleration, somewhere I got 0 acceleration also. Fine? That's it. Okay, ma? So after that, we will study instantaneous acceleration. Clear, ma? Now can you say what is meant by instantaneous acceleration? Previously we studied instantaneous velocity, no? Acceleration at a particular instant of time. It means particular instant means what? Time interval is very small. So small that it is almost equal to 0. That is called as instantaneous acceleration. Okay. So how to write the definition of this one? So okay. So A instantaneous can be written as limit delta t tends to 0, delta v divided by delta t. This is called as instantaneous acceleration. What is meant by delta v, ma? Change in velocity, delta t, change in time. So change in velocity by change in time is called acceleration. But if time interval is very small, then same acceleration converts into instantaneous acceleration. And instead of writing this total equation, I will write it just simply by dv divided by dt. So differentiation of velocity with respect to time. This is called as instantaneous acceleration. Are you able to understand, ma? That's it. So therefore, how can you define this one? Just acceleration at a particular instant of time is called as instantaneous acceleration. For example, if equation is given like this, velocity is equals to 3t square plus 4t plus 7, okay ma? So find instantaneous acceleration at t is equal to 4 seconds. That is the question. So velocity of a body is changing according to this relation. If time changes, velocity also changes. Definitely I can say velocity is not a constant, no? Velocity is definitely changing. Okay. So in this condition, how can you find out instantaneous acceleration at t is equal to 4 seconds? 28 you got. Okay, let us. Okay, ma? అది వెలాస్టిక్ కాసు పక్క ఇది వేరేది అది okay ma, so let us see this one. So equation of velocity is given now, 3t square plus 4t plus 7. Clear? And I am supposed to find out instantaneous acceleration. What is the equation for instantaneous acceleration? A is equals to dv divided by dt. This is the equation now. Instantaneous change in velocity divided by instantaneous very small change in time. Very small change in velocity, very small change in time. Clear ma? See here, delta is called change ma. Delta is called change. Small change, big change, anything. Okay. But d is called differential change. Differential change. Differential change means very small change, you can call it as differential change. Understood, no? So therefore, rules of differentiation yesterday only we studied now in the last class. So what is velocity here? 3t square plus 4t plus 7. Okay. So if you differentiate this one with respect to time, I will get equation of instantaneous acceleration. So differentiation of 3t square, 60. Differentiation of 4t, 4. Differentiation of 7, 0. So this is my equation for instantaneous acceleration. Okay. By using which equations we have calculated this one? So d by dx of x power n is equals to n into x power n minus 1. Okay ma? Similarly, d by dx of k x power n is equals to k into n into x power n minus 1. These are the equations. Where k is a constant, you can take out of this integration, differentiation. Clear, no? Now this is the equation for acceleration, but he is asking at 4 seconds, no? So here just you substitute 4. Therefore, what I will get? So instantaneous acceleration at what time? At a time of 4 seconds is equals to 6 into 4 plus 4. 6 4s are 24 plus 8, 28 meter per second square. This is the instantaneous acceleration. Understood, Dhamma? That's all, very simple. Come on, make a note up to here. We studied for instantaneous acceleration, Dhamma. What was that equation? So A instantaneous is equals to dv divided by dt. This is one equation which we studied now, no? A is equals to dv divided by dt. Now what I do is, to this equation of instantaneous acceleration, I will multiply this equation divided by dx divided by dx. Okay, ma? So I am multiplying by what? Dx divided by dx, or you can multiply with a ds divided by ds also. Okay. Now if I multiply by dx, will anything happen? Nothing will happen, no? Dx by dx is 1 only, no? So if you multiply anything by 1, nothing will happen. Understood, no? But what I can do is, so if you take these two under one ratio, and these two under one ratio. Let us see what will happen. So A instantaneous is equals to dx by dt, and what are the remaining terms now? dv divided by dx. My equation has converted like this now. So these two I have taken one under one ratio, and remaining terms I have taken under another ratio. Okay. And now can you say what is a dx by dt? Instantaneous velocity. X is nothing but displacement. No? Displacement by time is called velocity. Clear now? So therefore, A instantaneous is equals to v dv divided by dx, where v is called v instantaneous. So this is another equation to calculate acceleration. Understood, Dhamma? So what was the first equation we have derived? The first equation is A is equals to dv by dt. Another equation is v dv by dx. Clear? Now can you say this equation I can use in which condition? This equation I can use in which condition? I have derived two equations. No? It means there should be some purpose, no? Why we are deriving two equations. So what is the purpose of this equation? What is the purpose of this equation? Iti enduku? So this is the equation to calculate acceleration when velocity is changing with respect to time. Velocity is changing with respect to what? Time. Then we use this relation. Are you able to understand? No? This equation of acceleration we will use when velocity is changing with respect to displacement. Okay, ma? It means, for example, if here equation is given velocity is equals to 3t square plus 2t plus 1. Then here velocity is depending on time, no? Velocity is depending on what? Time. Then we will use this equation. Clear, no? Or if equation is given as velocity is equals to 3x square plus 2x plus 1. Now here velocity is changing according to displacement. X value changes, velocity also changes. Then we will use this relation. Okay, ma? So according to the data of the given question, either you have to select this equation or this equation. Is it understandable, ma? That's it. Very simple. Come on, make a note up to here. So let us see this question. So a body traveling with a velocity of 2 meters per second starts accelerating according to this relation. Then find the instantaneous acceleration after a displacement of 10 meters. That is the question, no? See, ma, here velocity is changing according to which relation? Velocity is changing according to displacement. No? Then what is the equation of acceleration? I have two equations of acceleration. No, ma? One equation is A is equals to dv divided by dt. If velocity is changing with respect to time, then I will get this equation of acceleration. But here velocity is dependent on displacement. No? So which equation I will use? I will use the relation A is equals to v dv divided by dx. Okay, ma? What is the initial velocity which is given? 2 multiplied by d by dx of, what is the equation of velocity he gave? So it is 3x square plus 7x plus 1. Clear, nama? So just do this calculation. So A is equals to 2 multiplied by, so differentiation of 3x square is how much? 6x. Plus differentiation of 7x is 7. Differentiation of 1 is 0. Clear, nama? So therefore A is equals to 12x plus 14. And he asked us to calculate x value at what distance acceleration at? X value is 10. Clear, nama? So therefore substitute this one. So 12 into 10 plus 14. So 120 plus 14 is how much? 134 meter per second square. So that is the required acceleration. Understood, nama? That's it. So any idea, ma? Particle is moving according to this relation. V is equals to root lambda. Lambda is correct. Clear, ma? So it is moving according to this relation, ma, where lambda is a constant. Then find the acceleration of the particle. Are you able to understand? So let us see how I can do this calculation. See, ma, here again velocity is depending on what? Velocity is depending on displacement only, no? So therefore can I use the relation A is equals to dv by dt? dv by dt equation can I use or not? Chappan tvarga ela use chestaraya? I cannot use the relation dv by dt in this condition. This relation I cannot use. Why? Because velocity is not changing with respect to time now. Velocity is changing with respect to displacement. So therefore which equation I have to use? A is equals to v dv divided by dx. So where v is called as the instantaneous velocity, which is already given. Clear, no? Now substitute here. So A is equals to, what is the instantaneous velocity? Root of 2 lambda is multiplied by d by dx of, again what is the equation? 2 lambda into s. Clear, no? So A is equals to root 2 lambda s multiplied by, here root 2 lambda is a constant, no, ma? So I will take out of this differentiation. Then I will have differentiation of root s. This is the value which I have. Clear? No? So acceleration is how much? So root lambda, 2 lambda into root s. Clear? So 2 lambda into root s is equals to, clear? Multiplied by differentiation of root s is how much? Differentiation of 2s is root s means s power 1 by 2 only, no ma? So 1 by 2 s power 1 by 2 minus 1. That is the equation, no? Differentiation of x power n is how much? N into x power n minus 1. So here root s means s power 1 by 2, no? So n into s power n minus 1. So 1 by 2 s power 1 by 2 minus 1. Jayanti vinali. Notes రాసుకోవడానికి కాదు మనం స్కూల్కి వచ్చేది వినటానికి. Okay? So therefore 2 and 2 gets cancelled, no ma? So therefore what is the acceleration I got now? So acceleration is equals to, clear ma? So lambda root s multiplied by 1 by root s. So root s gets cancelled. So acceleration is equals to lambda. Clear? No? That is how we do the calculation. Fine? So very simple. So this differentiation how we have done, understood, no ma? Root 2 lambda s, how can I write? Root 2 lambda s can be written as root 2 lambda multiplied by root s. Root 2 lambda is a constant, no? So I am taking out of differentiation. And then differentiation of root s. So it is 1 by 2 s power 1 by 2 minus 1, or you can simply say 1 by 2 root s. Okay, ma? So differentiation of x power 1 by 2 is how much? 1 by 2 root x. Directly you can say. So or if you want to do with the help of n into x power n minus 1, then you can do like this. Clear? That is the answer which I got. Come on. He is asking us to find out acceleration also, no? Now how can I calculate acceleration? So displacement, if I have differentiated with respect to time, I got velocity equation. Now from velocity equation, again how can I get acceleration equation? Cheppandi. Again differentiate velocity with respect to time. That's what we studied, no? So acceleration is what? dv divided by dt. Instantaneous acceleration is nothing but change in velocity divided by change in time, or you can say differentiation of velocity. So what is the velocity equation I got? Velocity equation is difference d by dt of, clear ma? So k by alpha e power minus alpha into t. This is the equation which I got. Now here k by alpha is a constant, no ma? K by alpha is a constant. Take it out of differentiation. So k by alpha. Now differentiation of e power minus alpha t. E power minus alpha t only. And at I have not differentiated, no? So differentiation of minus alpha t. Cheppandi. Minus alpha. Chain differentiation we are doing. So which function we have differentiated? E power minus e power x I have differentiated, which is e power x only. One more alpha is there. So then alpha get cancelled, no ma? So this alpha I can remove here. This alpha also I can remove. So this alpha and this alpha will get cancelled, no? There is no alpha, only k is present. Clear? So up to here it is clear, no ma? So k, differentiation of e power x only, and differentiation of minus alpha t is minus alpha. So therefore what is alpha value I got? Acceleration value is how much? Acceleration is equals to minus k alpha e power minus alpha into t. So this is my equation for acceleration of the particle. So I got one equation for velocity, one equation for acceleration. Now he is asking one more question, Nama. You are supposed to find out initial values also. So how can I calculate initial values? What is meant by initial values first of all? So initial values means, clear ma? Time is equal to 0. That is when you started observation. Clear no? So what is the equation for velocity? V instantaneous is equals to, clear ma? So k e power minus alpha into t. Understood no? So if you substitute t is equal to 0, this total term will become 0 no? Then e power 0. E power 0 is 1. 1 into k? K. So therefore what is my equation for instantaneous velocity? K is my answer. That's all. Similarly you calculate equation for initial value of acceleration. Come on, try change. See what is the answer you will get? Minus k into alpha. That's it. Okay ma? So similarly, acceleration equation minus k alpha multiplied by e power minus alpha into t. That's all. Here also you substitute 0. This term will become 0. E power 0 will become 1. So therefore, acceleration is minus k into alpha. So these are the initial values of velocity and initial values of acceleration. That is my required answer. Fine. Divided by change in time. This is what is called as acceleration number. Clear? And can you say this is what kind of acceleration? This is what kind of acceleration? This is instantaneous acceleration. Very good. So this is what kind of acceleration? This is instantaneous acceleration. What is meant by instantaneous acceleration? Already we have studied, no? So what is meant by instantaneous acceleration? Acceleration at a particular instant of time. Very good. That is called as instantaneous acceleration. Are you able to understand now? So already we have studied that acceleration limit delta t tends to 0, delta v divided by delta t. This is the actual definition of instantaneous acceleration. No? Clear, no? So what is meant by instantaneous acceleration? So change in velocity divided. Just super. So limit delta t tends to 0, delta v divided by delta t. That acceleration we call it as instantaneous acceleration. Clear? So for example, if a velocity is 3-dimensional, what is meant by velocity is 3-dimensional? I can write v dash is equals to vx I cap plus vy j cap plus vz k cap. For example, if I write velocity vector like this, okay. Now can you say what is the meaning of this velocity? E velocity meaning ఏమిటి? V dash is equals to vx I dash plus vy j dash plus vz k cap. What is the meaning of this vector? Can you say? Chapandi. So this velocity has a component along x-axis also. This velocity has a component along y-axis also. Same velocity has a component along z-axis also. అదే కదా దాని అర్థం? అవునా కదా? So therefore this velocity has some component of velocity along x-axis, y-axis as well as z-axis also. Okay. So if velocity is 3-dimensional, then acceleration also will be 3-dimensional. Clear number? So if velocity is along 3-dimensional and velocity is changing along all the 3 dimensions, it means velocity is changing along x-axis also, velocity is changing along y-axis also, velocity is changing along z-axis also. Then in that condition, what is my equation for instantaneous acceleration? Instantaneous acceleration is equals to d by dt of, clear now, velocity. And what is the velocity vector we have? Vx I cap plus vy j cap plus vz k cap. This is what I have now. Clear now? Then you can write this one as d vx divided by dt I cap plus d vy j cap divided by dt plus d vz divided by dt k cap. I can write like this. Are you able to understand? Now what is meant by dvx divided by dt I cap? What is the meaning of this equation? So this is the acceleration along x-axis. This is the acceleration along y-axis, and this is the acceleration along z-axis. Because change in velocity by time is nothing but acceleration, that already we have studied. No? Change in velocity by time is nothing but acceleration. So therefore what I can write? Therefore I can write, clear? So A instantaneous is equals to, so ax I cap plus ay j cap plus az k cap. I can write like this. So this is my equation for instantaneous acceleration. If body is having acceleration along x-axis also, along y-axis also, similarly along z-axis also. Are you able to understand? Come on. Make a note up to here, then I will give you one question. Try to answer that particular question. So see this given question. A particle describes an angle theta in a circular path with a constant speed v. Clear ma? So find the change in velocity and average acceleration. So these are the two values which you are supposed to calculate. Clear? So first let us try to draw a diagram of this one. So consider this is the circular path in which body is traveling. Okay. So considered he started from here. So let this initial velocity be v1 dash. And after some time the particle has reached up to here. Clear number? So this velocity we will call it as v2 dash. And by this time how much angle it has covered? It has covered an angle of theta. That's all. But what he is saying that it is covering an angle theta with a constant speed v. So velocities are definitely changing, because velocity is what kind of quantity? Velocity is a vector quantity, no? So as direction changes, velocity definitely changes. But he is saying speed is not changing. Are you able to understand me? So here also speed is v, here also speed is v only. Speed does not depend on direction, no? It is a scalar quantity. Clear? But velocity definitely depends on direction. It is a vector quantity. So here what is the direction of velocity? In this direction. Here the direction of velocity is in this direction. Clear now? Velocity has definitely changed. So you can write v1 dash is not equal to v2 dash. It means this velocity and this velocity, they are not equal. But the speeds are definitely equal. So speed here v, here is speed v, both of them definitely they are equal. So that is the first point which you should understand. Are you able to understand? Okay. So then what he is saying, it is covering an angle theta, then you are supposed to find out the change in velocity. What is meant by change in velocity? Ma? Change in velocity means what? Change in velocity means what? Come on. Chappal thoraga. Change in displacement by change in time. But here we don't know what is the displacement. Clear now? So what I do is, change in velocity in vector form, how can I write? v2 dash minus v1 dash. This is how I write in vector form. So what is meant by v2 dash minus v1 dash? Final velocity minus initial velocity. So change is always final minus initial. Change ante already chadukunnam kada manam. Change means always final minus initial. So final velocity minus initial velocity will give the change in velocity. Are you able to understand? So what is the final velocity here? This is the final velocity, no? So this velocity v2 dash, this is my final velocity. Then what is my initial velocity? My initial velocity is this one. So this v1 dash is my initial velocity. So this is my final velocity direction, initial velocity direction. Are you able to understand? Okay. But what I want v2 dash minus v1 dash, no? Ade kada naku kavalsindi. v2 dash minus v1 dash. So how can I write this one? It means this minus v1 dash, just I have to write in opposite direction this, then this will become minus v1 dash. That's all now. And what is this angle? So if this angle is angle theta, so here angle covered is angle theta only. No? So the angle between a v2 dash and v1 dash is also angle theta only. So if this angle is angle theta, then what will be this angle? 180 minus theta. Yes. So this angle will become 180 minus theta. Okay, ma? So therefore, magnitude of change in velocity, how can I calculate? In vector form, this one, that's all. This is my change in velocity, which you can write to delta v dash. Okay. In scalar form, how can I write? In scalar form, I can write. So change in velocity is equals to square root of v1 square plus v2 square plus 2 v1 v2 cos 180 minus theta. This is how I am supposed to write. Why I am taking cos 180 minus theta here? Okay. Now can you say why I am taking cos 180 minus theta in this condition? Can you say anybody? Yes, because I am not supposed to take the resultant of v2 dash and v1 dash. Are you able to understand, ma? If I take the resultant of v2 dash and v1 dash, then it becomes addition of vectors, no? It becomes addition of vectors v2 dash plus v1 dash. But I am supposed to take the resultant of which two vectors? I am supposed to take the resultant of v2 dash and minus v1 dash. And angle between them is how much? 180 degrees. 180 minus theta. Clear, no? So what is the speed of this one? V. Speed of this one is also v only. So instead of v1, I can write v. Instead of v2 also, I can write v only. Are you able to understand? So therefore, change in velocity is equals to square root of v square plus v square, and cos 180 minus theta is minus cos theta, no? So minus of 2v square cos theta. So this is the answer up to which I got. Understood, no? Okay. So therefore, delta v is equals to, now if I take v square plus v square, 2v square if I take common, then what I am left with? I am left with 1 minus cos theta. Clear, no? Okay. And according to trigonometry, what is 1 minus cos theta? 1 minus cos theta is equals to 2 sin square theta divided by 2. So this is the equation according to trigonometry. Are you able to understand? So 1 minus cos theta is how much? It is 2 sin square theta divided by 2. Now take this value, substitute here, then you see what is the answer you will get. Okay, ma? So change in velocity is equals to square root of 2v square multiplied by, instead of 1 minus cos theta, I will write, so 2 sin square theta divided by 2. So this is the equation which I will write. So then what is the total value I will get? 4v square sine square theta by 2. So therefore it is equals to 2v sine theta divided by 2. So this is my equation for change in velocity. Have you understood, all of you? Clear? That's all very simple. Clear? So this is the equation which you may be confused. So 1 minus cos theta is equals to 2 sine squared theta by 2. Clear, no? That's it. So then he is asking second question also. No? What is the second question? He is asking average acceleration. That's the second question, no? I rubbed this one. Average acceleration. Okay. Now anybody, can you say how can I calculate average acceleration? Completed now this one? So average acceleration, how can I calculate? Anybody, can you say? So average acceleration definition, total acceleration divided by time taken. That's all. Total change in velocity, sorry. So total change in velocity divided by total time. Okay, no? So average acceleration can be written as change in velocity divided by time taken. That's all, no? Okay. So change in velocity already I have calculated. What is the change in velocity? 2v sine theta divided by 2. That I have calculated. Time, is it given? Time, is it given? No. Then how can you do? There is no concept of time in this condition. No? Time is not at all given. How can you calculate time? Can you see? No. This is equal to, displacement is equals to velocity into time. Which equation you want to use? Sima. So in this circular path, clear now, particle has started from here and particle has reached up to here. This is what I am considering now. So here speed is v, here also speed is v. So by this time how much angle it has covered? It has covered an angle of theta. Are you able to understand? And body is traveling with uniform speed, no? Speed, is it changing? Speed martu unda? No, speed is not changing. It means body is traveling with uniform speed. So what is the equation of uniform speed? Displacement is equals to velocity into time. This is the equation we use when body is traveling with uniform velocity. But is body traveling with uniform velocity? No. Body is traveling with uniform speed. Then what is the equation? Instead of displacement, I will write distance. Instead of velocity, I will write speed. And instead of time, I will write time. So this is the equation which I can use when body is traveling with uniform speed. Are you able to understand the difference? Both equations are of same format only. Are you able to understand, ma? So this is the equation when body is traveling with uniform velocity. This is the equation when body is traveling with uniform speed. So you should not be confused in both of them. Are you able to understand? Okay. So therefore, what I want time only, no? So therefore time is equals to distance divided by speed. Speed I know. Speed is v only, no? Then this distance, how can I calculate? This is the distance traveled by the body in this particular time, no? So it has started from point A and it reached up to point B. So this distance is nothing but the distance which we are required to calculate. Now how can you calculate this length of this arc AB? If I find out the length of the arc AB, that is my distance, no? How can I calculate? Do you have any idea? See, ma, when can you say me? Very good. Very good. So here when body is traveling a particular angle and it has covered the length of the arc is L, then we have a relation between theta, L and radius of the circle R. Are you able to understand, no? And the relation is theta is equals to L divided by R. This is the relation. Theta is equals to L divided by R. What? Radius of the circle, let us assume to be R. He did not give anything, no? Let us assume radius of the circle is R. Are you able to understand? So theta is equals to L by R. This is the relation. And in this condition, which is the distance? Distance is nothing but L only, no? Distance is nothing but L. So therefore L, how can I write? L is equals to theta into R. That's all, no? So therefore what is the time taken? Time taken is equals to, distance is nothing but L only, no? So instead of d, what I can write? I can write theta into R divided by speed is v. Okay. So take this time taken, substitute here, then you will get the equation for average acceleration. Change in velocity already I have calculated now. What is the change in velocity magnitude? 2v sin theta divided by 2. And what is the time taken? Time taken is theta into r divided by v. So just divide both of them. That is my required answer. Fine. Understood, Amma, how we are doing? So this is the relation which you are supposed to remember here. Theta is equals to L by R. Okay. When body has covered an angle of theta, length of the arc is L and radius of the circle is R. Fine. Come on. So divide chain number, divide both of them. So therefore average acceleration, what I will get? Average acceleration is change in velocity divided by change in time. Change in velocity, 2v sin theta divided by 2. And what is the change in time taken? So it is theta into r divided by v. So this v I can take upwards also. So it will become 2v square sin theta by 2 divided. Say this question. So a particle starts moving rectilinearly at t is equal to 0 such that its velocity v changes with time t according to the relation v is equal to t square minus t. Okay, ma? So find the time interval for which body retards. Okay, ma? So you are supposed to find out that interval of time where body is undergoing retardation. What is meant by retardation? Negative velocity. That means its velocity direction has changed. That is called as retardation, no? Its velocity is continuously reducing. So that time interval you are supposed to calculate. Try Jastara Kasir. Try for 2 minutes and see what is the answer you will get. Is equal to 0 such that its velocity v changes with the time according to this relation. So velocity is changing according to this relation. V is equals to t square minus t. Understood, Nama? Then find the time interval for which body retards. Okay. So initially let us consider this is a body and it is traveling in which direction? It is traveling in this direction. With how much velocity? With a velocity of v. Are you able to understand? Okay. Now when this body is traveling in this direction, what is the condition for acceleration or retardation? Positive acceleration means what? Negative acceleration means what? What is meant by positive acceleration? What is meant by negative acceleration? Can you see? If velocity increases, then it is called as positive acceleration. Correct, Nama? So velocity direction is in this direction. I can say v dash is in this direction. Acceleration also, if it is in the same direction, then I can say that velocity of the body continuously increases. Positive acceleration means what? Acceleration is a vector quantity, no? Acceleration is what kind of quantity? Vector quantity. So vector quantity means what? It will have a direction also. And which direction I am taking? I am taking velocity is in this direction. It means body is traveling in this direction. Acceleration is also in the same direction. Acceleration also in the same direction means what? So if velocity and acceleration, if they are in the same direction, it means what happens to the velocity of the body? Velocity of the body continuously increases. Speed of the body continuously increases. Are you able to understand, ma? So therefore here what is the condition I have to write? I have to write that if velocity and acceleration, are in the same direction, then what happens to velocity, ma? Then velocity of body increases. This is what will happen, ma? Velocity of the body continuously increases because velocity and acceleration, both of them, they are in the same direction. Are you able to understand? So therefore what I can say, velocity is positive, acceleration is also positive. Why? Because both of them, they are present towards a positive x-axis. They are present in which direction? They are present in positive x-axis direction. So if velocity is positive, acceleration is also positive. But that is not the condition which he is asking. No? He is asking which condition? He is asking the condition of retardation. Okay. Now can you say, by using this explanation, how can you define retardation? Retardation, how can you define? Velocity? Velocity negative. Decrease of what? Acceleration is not decreasing. Acceleration is always a constant. Can you see? Velocity is decreasing. So velocity will decrease in which condition? Very good. That is the condition. Clear, Nama? So body retards in which condition? Body retards when velocity and acceleration, they are in opposite direction. Are you able to understand, ma? When velocity is in one direction, acceleration is in opposite direction, then definitely you can say velocity of the body reduces. If one body is moving in this direction, you are applying force in backwards direction. Net force produces acceleration. No? Newton's laws we have studied. No? Net force produces acceleration. So therefore, if velocity is in one direction, acceleration is in opposite direction, then what happens to the velocity of that body? Decreases. It means if you take velocity to be positive, then acceleration should be negative. It means both of them, they should be in opposite direction. In that condition, you can say definitely velocity of the body reduces, or you can say it is negative acceleration, deceleration or retardation. Are you able to understand? Acceleration will be in which direction? Acceleration will be in the direction of net force. Acceleration eppudu ఏ direction lo untundi? Acceleration will be in the direction of net force. If you are applying force in this direction, acceleration also will be in the same direction. So body is moving in positive x-axis, you are applying force in opposite direction. Then what happens to the velocity of the body? Velocity reduces. That is called as retardation. Are you able to understand now? So therefore I say that body is traveling in this direction with a velocity of v, and you are applying a net force in opposite direction. If a net force is in opposite direction, what happens to this velocity? Reduces. So if acceleration is in this direction, F net is equal to mass into acceleration. No? So acceleration also will be in which direction? Ma? It is also in opposite direction. Are you able to understand? So therefore, if I say that if velocity is positive, then acceleration should be negative. Are you able to understand now? So plus into minus, minus. So therefore, I can write a dash dot v dash should be less than 0. A dash dot v dash should be less than 0. If I take the dot product of these two, it should be less than 0. Why it should be less than 0? Dot product gives only magnitudes, no ma? Dot product will give what? Only magnitude of a resultant vector. Are you able to understand? So if I multiply acceleration and velocity, one is positive, another one is negative. Their product should be negative. It means it should be less than 0. Negative means less than 0 only, no? Are you able to understand? Okay. Now velocity vector is already given, no? What is the velocity vector? Velocity vector is equals to t square minus t. Are you able to understand? No? Then how can you write acceleration? Acceleration, how can you calculate? dv divided by dt is nothing but acceleration. No? Change in velocity by time is nothing but acceleration. It means you are supposed to differentiate this velocity. If you differentiate velocity with respect to time, what you will get? Acceleration. So differentiate this one. So d by dt of velocity. Velocity is a t square minus t. Understood, Nama? So now can you say what is the differentiation of t square? T square. 2t. Differentiation of t square is 2t. Are you able to understand? Ma? So therefore I will write acceleration is equals to 2t. Differentiation of t? Differentiation of t is minus 1. Because I have minus t, no? dt by dt. dt by dt, 1. We have minus here, no? So minus 1. So therefore this is the equation of velocity and this is the equation of acceleration. So therefore if you multiply a into v, then it should be less than 0 because negative velocity is in one direction, acceleration is in opposite direction. It means if you take the product of these two, it should be less than 0 or you can say negative. Understood now? So therefore what is the acceleration equation I got? 2t minus 1. What is the velocity equation already I have? T square minus t. It should be less than 0. Are you able to understand? So now see what you can do here. Okay. So let us try to simplify this one. So 2t minus 1. Here if I take a t common, then it is a t minus 1 should be less than 0. This is the term which I got, Nama. So therefore, for this total value to become less than 0, there are two conditions. What are the two conditions? Time can be never less than 0, Nama. Time is always positive. Time can be never negative. So therefore, two conditions are possible. What completed now this one? So what are the two conditions which are possible for obtaining this condition? So I am writing case number 1. Clear, ma? Case number 1 is 2t minus 1 should be less than 0 and t minus 1 should be greater than 0. This condition is possible, no? 2t minus 1 less than 0. Less than 0 means what? Negative. T minus 1 should be greater than 0. T minus 1 greater than 0 means what? It is positive. This case is positive. Clear? Another case which is possible is, case number 2 which is possible is 2t minus 1 is greater than 0. T minus 1 should be less than 0. This condition is also possible. No? Sima, the product of these two should be less than 0. It should be negative. Negative can be possible in which condition? One should be positive, another one should be negative. So in the case number 1, I am taking this one is negative, this one is positive. Plus into minus, minus. In second case, what I am doing, this one I am taking positive, this one I am taking negative. So out of these two conditions, which condition is possible? First one. Why not second one? So let us see. This is not time less than 0, no? T minus 1 less than 0. Kada? This t cannot be 0, but these two can be 0, less than 0. Clear? Let us see. So in case number 1, 2t minus 1 is less than 0. So 2t is less than 1. So t is less than 1 by 2. Can I write like this? 2t minus 1 is less than 0. 1 I am taking to the other side. So 2t is less than 1. So t is less than 1 by 2. Okay. Similarly, let us see this condition. So t minus 1 is greater than 0. It means t is greater than 1. Clear, Nama? So t is less than 1 by 2. T is greater than 1. Is this condition possible? T should be less than 1 by 2. 1 by 2 kanna takkuva. Kani 1 kanna ekkuva. This condition is not at all possible. So this condition is not possible. Are you able to understand? Let us see the second case. What is the second case which we have here? Second case is 2t minus 1 is greater than 0. So 2t is greater than 1. So 2 is greater than 1 by 2. Clear, Nama? One more condition. T minus 1 should be less than 0. So t should be less than 1. Is this condition possible, Ma? T should be greater than 1 by 2, but less than 1. So time can be present in between this condition. No? So therefore this condition is correct. This condition is not correct. So this is the time interval in which body is retarding. This is the time interval in which body is retarding. What is meant by retarding? It is undergoing negative acceleration. Speed of the body, velocity of the body is continuously reducing. So this is the time interval. So t is greater than 1 by 2 second, but it is less than 1 second. It means in the time between 1 by 2 and 1, body is definitely retarding. Are you able to understand? That is how we can do this.